Yes, we are now into the next topic, which is finance, with some real life applications. If I look at the content area for our exams, it comes in paper 1, as you can see here. It comes under paper 1, and finance and growth in grade 12. It is, you can see it's grade 12. It is about 15 marks, right? It's not a very difficult topic. We have very few formulas that we'll go through it, but the questions that appear for last 2 years has become so difficult that such an easy topic that we feel but has become difficult. The questions type are now not straightforward. So you must know a little bit of English. Language is important. So let's see how we are going to apply that. This is the information sheet that I picked from the exam guidelines. Now in this you will find those formulas here. Okay, this formula, this is your simple interest, a plus 1 plus in, a plus 1 minus in, and this is your depreciation. Now this is your compound depreciation, compound decay, and this is your this is your compound decay, and there is other one. Yeah, there is a compound interest, there is a compound growth. Okay, so we have learned in grade 11 different types of depreciation. One is A is equal to 1 minus in. This is called a straight line depreciation or simple decay, right? Straight line or simple decay. That's what we have learned in grade 11. A is equal to P 1 minus I to the power of n. This is called the compound decay. This is called compound decay. Or we also call them as reducing balance, right? We also call them as reducing balance. Yeah. So these are, and we know simple interest and compound interest that we have been learning right from. This is simple interest and this is a compound interest that we have been learning right from earlier grades. Now in grade 12 we are going to learn some additional formulas on grade 12, some additional formulas on our finance. So here you see here these two formulas here, right? One is written as F is equal to, and other is written as P is equal to, right? So we are going to learn these two one, which we call them as annuities, but we'll discuss. So simple interest, it is OA is equal to 1 plus in. So this is, we call them as growth. This is our growth, right? The money appreciates. This is money depreciates, right? This is depreciation, or we call them as decay. So mathematically we prefer to use the word decay, but since we are dealing with finance, we use the word depreciation, which is a more technical financial term. But this way is continue to still growth as growth, and finance also we call them also as interest, implying growth. But in mathematics, interest can be depreciation as well as appreciation. Now this is a growth and this is your depreciation. So 1 plus is growth, 1 minus is depreciation. That's on simple interest. Now on compound interest, we have also again two formulas, 1 plus I to the power of n. I hope you can see the power of n, right? Now this is the one for the compound interest, and this is the compound interest for single investment. And now this is another one here, the compound interest. This is a compound decay, we call them as compound decay, but there's only one investment. on a particular investment. So these are the two formulas that we have learnt on compound interest. But in fact, if you look at very simple, if you, instead of learning four formulas, you can actually learn in two of them actually. So it is A is equal to P times 1 plus or minus IN, right? For plus for growth and minus for decay. And the other one is PA is equal to P times 1 plus or minus I to the power of N. Again, if it is plus, it is a compound growth, and if it is minus, it is depreciation or reducing balance depreciation. Let's also understand that we have to find A stands for amount, P stands for principal, I stands for a rate of interest, and N stands for the period of investment or term of investment. And the questions in grade 12 can also come based on compound interest or simple interest formula, right? So we have four variables here: A, amount; P, principal; I, interest; and N, term of investment. So now the question can also come based on these two formulas or four formulas to calculate the fourth one. I mean, other three information will be given. We have to find the third one. A will be given. You may be asked to find P. P will be given. You may be asked to find I. A, P, and I will be given. You may be asked to find N. So the questions can come based on determining the fourth unknown. Right. So I want to understand this part now very clearly before we proceed, and that is to calculate P. I will write P. I'll have to divide 1 plus I to the power of N on both sides, right? So here I prefer to write instead of writing A divided by 1 plus I or minus I, depending upon the situation, divided by N, right? I prefer to write as in exponential form, that is A times 1 plus or I to the negative N. So I apply the laws of exponents here, right, to write like this. So when it is minus N, I am finding the principal, right? And if it is plus N, I am finding the amount. So I am no longer going to call A as P. As we progress, we will understand I am going to use them as different names, but we will see. I am discussing now grade 11, one or two basic questions that may continue to ask in grade 12. And here, the value of laptop depreciates on a reducing balance method at a rate of 13.4% per annum. Calculate the original value of the laptop given that it depreciated to 7,210 over a period of 5 years. So we have to first understand what all information is given. So you can straight to know what all information we require. We require A, we require P, we require I, we require N. So that will help us to understand which variable of these four we have to determine them. So which information is given? The value of the laptop depreciation reducing balance method. Therefore, I know I have to use this formula, reducing balance. I have to use this formula. From this formula is also given in your information sheet. So please refer to your information sheet, right? Now, interest rate is given. Interest rate is given to be 13.4% per annum. Okay. Now, what is my N? Calculate the original value. I have to calculate the original value. This is my original value. Principal is my original value. So I have to determine this one, right? So this is unknown now. And then depreciated to. So that is what depreciated to. That means its amount is 7,210. So a little bit of English language that will tell me that this is depreciated to. That means that is the amounts to 7,210. Increased to 100 means the amount has increased to 100. Increased to 50 means new amount is 50. Or amount decreased, right? Number decreased 2. That means that is my new value. So depreciated 2, the amount is my 7,250 over a period of 5 years. So that will tell me my period is n is equal to 5. So the question now here is to find P. So what I'll do here, as I told you, P is equal to, yes, now, so P is equal to, I told you, A is equal to 1 minus I to the power of negative n. So I will use that one here. Now I write model information. A is given to be 7,210. 1 minus I is given to be 13,4 percentage to the power of negative n. Right? That is negative is equal to negative 5. Right? So I use my calculator now to calculate the value of P. So 7210 times, I open the brackets, 1 minus, my rate of interest is 13,4. So it's 13,4. Now percentage, where's my percentage? This or the brackets here, shift these brackets and then close the brackets to the power of negative 5. So I input as I written down here and input the value in the calculator and I press equal to and I get 14,802,87. So my answer is 14,802. 14,802,87. So this is it's always better to write in rands, though there will be no marks for writing the rands or no rands, but it's always a good practice. So this is my final. This is a principle. That is, the original amount of the laptop is 14,802 and it will depreciate to 7,210 after 5 years if the rate of depreciation is 13,4% on a reducing balance method. Now let's look at the second question. The question here is to calculate the effective rate of interest if an investment offers 8.2% compounded quarterly. So here there's no formula information sheet on calculating effective rate of interest. So I'm not using I will be using only the formula that is given in the information sheet, right? I prefer to use that, though the textbooks gives different methods to calculate the effective rate of interest or the nominal rate of interest, right? So to me, A is my effective rate of interest and P is effective rate. A minus P is my effective rate of interest and the I is my nominal rate of interest. Okay. So what I'll do here is it's a compounded quarterly, it's a growth, right? So A is equal to P times 1 plus I to the power of n. So we do not know what is A. We assume P to be 100 rands. I is given to be 8,2% compounded quarterly, right? So it is compounded quarterly. We do that. Now effective rate of interest is always annual, right? Is always annual, right? So we want to calculate what is the interest rate after, what is the amount after 1 year. So my period is always 1 year. So this will remain if the information is on to calculate effective rate of interest or nominal rate of interest. I assume principal to be 100. Whatever principal is given in the question, no, I ignore that. And I assume my principal to be 100 and my year as 1 year. We cannot calculate effective rate of interest for 5,000 rands for 2 years. We always calculate interest for 100 rands for 1 year. Always remember that one. So now what I do here is 100 times 1 plus I is said to be 8,2% divided by 4. 4 why? Because it's compounded quarterly divided by 4. And then how much is this? So it is 4 times 1, right? 4 this 4 will come here, this 4 will come here, times here. So there are 4 quarters, right? And so that is how I get this divided by 4. So I input this value in my calculator. I am using my calculator here. So what I do here, 100 times 1 plus I. What is my I is 8. So I put, there's a fraction here. Therefore it is 8,2 percentage, right? And it's divided by 4, and I close the brackets to the power. So it's 4 times 1. So I input this value in the calculator, and the calculator is going to be 108,45. You can see that. So I got the answer as 108,46 as a round off to 2 decimal places. So this is my amount. So what is my interest? How much money I gained for 100 rands? So it is going to be 108,46 minus 100, which is going to give me 8,46 percentage per annum. So this is my effective rate of interest. That is 8,486 percentage per annum. What it wants to mention is that if let me try to explain what it wants to understand. Let's understand this very clearly. What is meant by effective rate of interest? What it wants to suggest is that with 8.2 percentage compounded quarterly, this is compounding quarterly, will yield me the same if the interest rate is 8,46 percentage compounded annually. Therefore, it's a good practice to write PA. So these two are equivalent. 8.2 percentage approximately, because we rounded off. 8.2 percent compounded quarterly is same as 8.46 percentage per annum compounded annually. Though that is why we call them as annual effective rate of interest. Now, next question is interesting, which we have not done in grade 11, though it's a grade 11 type of question. Those who know it might be, those who are doing accounting may be able to do this, unless we apply logarithm. If you are going to apply logarithm in our finance to answer this question. That is, Tembile invests 3,500 in the savings account, which pays 7.5% per annum compounded yearly. After an unknown period of time, his account is worth 4,044,69. For how long Tembile invests his money? Let's understand what all information is given. And invest an amount of, that means the investment amount of, that is my A. So that is my P. Investment amount, that is my P, 3,500 rands, right? And then interest rate is given to be 7.5% compounded annually per annum. Compounded yearly, compounded annually. After an unknown period, so unknown period, that means my period is unknown, therefore n is unknown, therefore I have to calculate n. And my A is account is worth. So you must understand these terminologies that they use, and you must be able to distinguish which is P and which is A. The first thing, very important to understand, you have to distinguish which is A and which is P from the question. So that is important. Now it is compounded yearly. So you can see it is actually is investment, right? That is my growth. So this investment will tell me that it is a growth, right? Depreciation is decrease. Now this is this is a compound interest growth, 1 plus I to the power of n. I have to find an. I have to find, and that means I have to make n the subject of the formula. Those who can learn it by those who can learn understand this an is equal to, some textbooks will tell you this formula as this, a over p, right? Or you can learn it, but let's deduce this formula, or let's make n the subject of the formula. So what I'll do now, I have to make a divided by p is equal to 1 plus I to the power of n. Remember, I have not made any substitutions. First I will make n the subject of the formula. Now what it is, n, how this n is an exponent. As you can see, n is an exponent, and then they have to make n the subject of the formula. Therefore, to make the exponent the subject of the formula, I use logarithm. So what I do here, it is logarithm of 1 plus my base remains base, a over p is equal to n. So this is made n the subject of the formula. Now I use my calculator and substitute. That is, now n is equal to log 1 plus I. I is what? 7,5%, right? Compounded annually, so it's divided by 1 times A. A is how much? 4044,69 divided by 3,500. So I input this value in my calculator. So I am going to use my calculator here. So I use this logarithm function here, logarithm with the base. So logarithm, the base, my base is 1 plus 7,5 percentage, and then I press logarithm of. So I first press the base. Now of, you can see there is a over p, that is 4,044,69 divided by p. My p is 3500. Cool. So I use my calculator and I got the answer as 2. Yo, this calculator is very quick. And I write my answer as 2, right? N is equal to 2. So it's always a good practice to write as 2 years. For 2 years, if the investment from 3,500, my investment will grow to 4,044,69 at the rate of 7,5% compounded annually. So this is a question that we can also expect in grade 12 to find the value of n, both for depreciation and for growth.